What is derived algebraic geometry? It's where homotopy theory meets algebraic geometry. It's the next generation of geometric mathematics. Let's look at the historical development of derived algebraic geometry. In the 1950s and 60s, Grothendieck developed scheme theory and homological methods. Later, in the 1990s, Kontsevich proposed the hidden smoothness philosophy. The core problem is that classical intersection theory fails when varieties intersect non-transversely. However, higher Tor groups encode the failure of nice intersections. A tensor product with L as a superscript B equals an expression involving P with a bullet superscript, tensor B d'. The derived tensor product captures all higher Tor information, not just the classical tensor product. Let us compare the classical and derived approaches. The classical approach is a tensor B, which ignores higher Tor groups. In contrast, the derived approach is a tensor with L as a superscript B, which incorporates all higher Tor information. The Serre intersection formula is bracket V1 intersect V2, close bracket, equals summation over I of -1 to the power of I times length of Tor. I as subscript R as superscript bracket M1, M2, close bracket. Higher Tor groups appear naturally in intersection theory of singular varieties. Let's see why higher Tor matters with an example: the union of two planes. The classical multiplicity is 3, which is length of A divided by I plus j. However, the actual geometric multiplicity is 2, which is summation of -1 to the power of I length of Tor. I is subscript bracket A by I, A by j, close bracket. From homotopy theory, the key insight is to replace commutative rings with chain complexes of commutative rings. Homotopy groups encode higher Tor information. The bridge between homotopy theory and derived algebraic geometry is E-infinity ring spectra. For structured ring spectra, pi0 of R equals a commutative ring, and pi minus I of R equals higher Tor groups. E-infinity ring spectra provide the homotopical refinement of commutative rings. Definition: a derived scheme is a locally ringed space in E-infinity ring spectra. That is, spec R, where R is an E-infinity ring spectrum. Applications and impact. Mirror symmetry. Homological mirror symmetry via derived categories. Moduli spaces. Derived moduli spaces with virtual cycles. Derived algebraic geometry provides a unified framework where intersection theory, deformation theory, and moduli spaces finally work together seamlessly. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.